Hi everyone, so welcome to your lesson 3 video. In lesson 3, we're going to focus on polynomial operations. Specifically today, we're going to focus on how to identify like terms and to simplify polynomial expressions by combining like terms. So this is going to be part 1 of lesson 3. So in order to know how to combine like terms, you need to know what a like term is. So a like term is a term that has the same variable, which is just another name for a letter, and the same exponent. So what do I mean by that? Well, let's look at some of the examples we have here first. So for instance, numbers. So the numbers 2 and 3 are both like terms. So you've been adding, subtracting, multiplying, and dividing like terms for many years now. So numbers are considered like terms because they both are constants, or in this case, they both are numbers. 3x and 2x. So 3x and 2x are like terms because they both have the same variable. They both have an x, and they both are being raised to the same power. So remember, when there's an x, there's a little imaginary 1. So they have the same variable and they have the same exponent. So those would be considered like terms. So the coefficients don't have to match, just the variables and the exponents. So 3x and 2y would not be like terms because if you notice, one has an x and one has a y, and we can't combine letters that are different with each other. So these have different variables. 3ab and 2ab would be considered like terms because they both have an a raised to the first power and they both have a b raised to the first power. So again, even though the coefficients are different, because they have the same letters, they are considered like terms. Now, you can have the same letter or same variable, you can have the same coefficient, but once the exponents are different, so there's an imaginary 1 here and a 2 here, they are no longer considered like terms because they have different exponents. And last but not least, 3xy and 2yx, they would be considered like terms because they both have an x, they both have a y, so because they have the same letters and they're raised to the same power, they are considered like terms. So combining like terms is the process of adding terms together only if they have the exact same variable with the exact same exponent. So let's go through a couple more examples and then you'll try some on your own. So 4x and 3. They are not like terms. The reason is, well, they both don't have x. So that's what we're going to write here. They both don't have x. They have different variables, or in this case, one doesn't even have a variable. So these are not like terms. 4x and 3y. Well, I said in order to be a like term, they have to have the same letter. And one has an x and one has a y. So x and y are different variables. So these would not be considered like terms. 4x and 3x squared. Well, they both have an x. However, this one's being raised to the first power, and this one's being raised to the second power. So these are not like terms because they have different exponents. And last but not least, 4x and 3x. Well, they both have an x. They're both being raised to the same power. So they are like terms because they have the same variable and the same exponent. So something you might want to note to yourself, you can have the same variable, the same exponent, and different coefficients. So different coefficients are okay. So let's write that down. Different coefficients are okay. Because when we combine like terms, those coefficients are actually going to change. So try some on your own. See if you can determine if numbers 1 through 6 are like terms or not like terms. All right, so let's go through each example together. So 4b and 2c. Hopefully you chose not like terms because one has a b and one has a c. So they have different variables. You can't combine them. Number 2. Hopefully you chose yes, that they are like terms. Remember, these are both constants or both numbers. You can definitely combine a 7 and a 2 together. So those are like terms. Number 3, these are not like terms. Why? Well, despite having the same coefficient and the same variable, the exponents are different. This has an imaginary 1 and that's got a 2. So those are not like terms. Number 4, let's see, same variable, same exponent. So yes, these are like terms. Different variables, same exponent and same coefficient, but because one has an x and one has a c, this one is going to be no, they are not like terms. And last but not least, x to the 4th power and a y, x to the 4th power and a y. Yep, these ones are definitely like terms because they both have an x and a y and they're raised to the correct exponents. So now that you know how to identify like terms, we're going to talk about how to combine like terms. So when I combine like terms, I like to use different colors so that I can group them because there may be more than one set of like terms in an expression. So for instance, a pair of like terms in number 1 would be 3x and x because they both have an x and they're both being raised to the same power. Another pair of like terms would be the 2 and the 6 because they're both constants. So I'm going to circle those in green. So what I have to do is I have to combine like terms and write my final answers in standard form. So let me think, what does standard form mean? Well, standard form means I have to put the exponents in order from highest to lowest. So if I'm going to put them in order from highest to lowest, I'm going to start with anything that has an x next to it. So I'm going to start with the 3x and the 4x. Now, when you combine like terms, the only thing you're really combining are the coefficients. You're going to keep the variable and the exponent. So here, if I'm going to combine 3x and 4x, I'm going to combine the coefficients. So 3 plus 4 is 7. And I'm going to keep my variable and the exponent. So 3x plus 4x is 7x. Same thing for 2 and the 6. Well, that's just basic arithmetic. 2 plus 6 is 8. So I'm going to add on a plus 8. So what you really just did is you simplified the expression by combining like terms. So see if you can do number 2. Combine like terms to simplify the expression. So like terms, remember they have to have the same variable and the same exponent. So x squared and x squared can go together. 2 and a negative 5 can go together. So remember I have to combine my coefficients. Well, what's the coefficient in front of x squared? Now remember, it's an imaginary 1. So this is really going to be 1x squared plus 1x squared. So 1 plus 1 is 2x squared. And then 2 minus 5, because remember you want to keep the sign in front of the number. Notice I circled the negative in front of the 5. 2 minus 5 is a negative 3. So this simplifies to 2x squared minus 3. All right, see if you can give number 3 a try. 3x squared plus 5 minus x minus 1. So the only like terms I have in this one are the 5 and the negative 1. So you might be saying, well, what do I do with the 3x squared and the negative x? Well, we're going to rewrite any terms that cannot be combined with anything else. So I can't combine 3x squared with anything, and I can't combine the negative x with anything. So I'm just going to rewrite them. But I want to make sure that I write them in standard form. So I have to think, okay, which term has the highest exponent? Well, this has a 2, and that has a 1. So the one with the 2 is probably higher. So I'm going to write the 3x squared first, then the negative x. And then the last thing I need to write is 5 minus 1, which is 4. So combine those like terms to get 4. So now it's in standard form, and I've combined like terms. So let's try number 4. See if you can combine like terms to simplify the expression in number 4. So we've got x squareds that go together. We've got constants that go together. And we have x's, so x squared and x's. So remember, I want to write this in standard form. So I am going to pick the one with the highest exponent, which is the x squared. So 7x squared minus 5x squared. 7 minus 5 is 2, so this is 2x squared. Then I'll do the pink next, because that has the next highest exponent, so 3x plus x. Remember, there's a little imaginary 1 there, so that's 4x. And then the constants. Negative 6 plus 9 is a positive 3. So that's what that simplifies to, 2x squared plus 4x plus 3. Let's do one more together, and then you can try some on your own. So number 5, see if you can combine like terms, and there are a lot of different things going on here. So the x's will go together, the y's will go together, and the z's will go together. So we got 3 different letters. So you actually can pick whichever letter you want to start with. They're all raised to the same exponent, so no one is bigger than the other. So maybe you want to do it in alphabetical order. So I'm going to start with the x's. So 2x plus x is really 2x plus 1x, which is a 3x. Then I'm going to go to the y's. Positive y and a negative y. This is really a positive 1y and a negative 1y. And 1 minus 1 is 0. So if it's just 0, then that must mean that those y's are just going to cancel out. We don't have to write plus 0. We can just get rid of them. And now my z's. 3z plus 1z is a 4z. So the y's cancel out, and now you're just left with an x and a z. Now, because there are no higher exponents than one variable over the other, we can actually write this also as 4z plus 3x. So if you wrote it that way, that would also be correct, either one. So see if you could try 6, 7, and 8 on your own. And when we meet back in class this week, we'll go over those 3 together.